US Physics Olympiad year 2018 USAPHO. Problem B2. In this problem, use a particle-like model of photons. They propagate in straight lines and obey the law of reflection, but are subject to the quantum uncertainty principle. You may use small angle approximations throughout the problem. A photon with a wavelength lambda has traveled from a distant star to a telescope mirror, which has a circular cross-section with radius big R and a focal length f much greater than r. The path of the photon is nearly aligned to the axis of the mirror, but has some slight uncertainty delta theta. The photon reflects off the mirror and travels to a detector, where it is absorbed by a particular pixel on a charge-coupled device CCD. Suppose the telescope mirror is manufactured so that the photons coming in parallel to each other are focused to the same pixel on the CCD, regardless of where they hit the mirror. Then all small cross-sectional areas of the mirror are equally likely to include the point of reflection for a photon. Question A. Find the standard deviation delta R of the distribution for R, the distance from the center of the telescope mirror to the point of reflection of the photon. Question B. Use the uncertainty principle delta R multiplied by delta P greater or equal to reduced Planck constant over 2 to place a bound on how accurately we can know the angle of the photon from the axis of the telescope. Give your answer in terms of R and lambda. If you were unable to solve part A, you may also give your answer in terms of delta R. Question C. Suppose we want to build a telescope that can tell which high probability whether a photon it detected from Alpha Centauri A came the left half of right half of the star. Approximately how large would a telescope have to be to achieve this? Alpha Centauri A is approximately 4 by 10 power 16 meters from Earth and has a radius approximately 4 by 10 power 9 meters. Assume visible light with a lambda equal 500 nanometers.